Alright, hey guys, my name is Andrew and I'll be teaching you guys about binomial distributions today. And I'll be telling you when a random variable is binomially distributed. So, in order for that to occur, or in order for you to realize that, there are four main criteria or aspects that an event needs to have in order for you to know that it can be binomially distributed. So there are four main aspects like I mentioned before, and I'll be going through each of them before we go on to any examples or explanations. The first one is that there are two outcomes to the random variable, which are generally characterized as success or failure. So the first one is that there are two outcomes, and that they are characterized as success or failure. So that's the very first aspect. The second one is that there are a fixed number of trials. Let me just write that down. Fixed number of trials. So this means that in an event there's a number of trials that do not change. And relating to the second aspect, the third one is that each trial is independent. Each trial is independent. So this means that the probability or the outcome of one trial does not affect the outcome of the next, hence being independent, as we learned in our previous unit. And the fourth aspect is that this is a general rule of thumb. This is the general rule of thumb, but the probability of success, so the probability of success, failure equals to 100% of the sample space. So these are the four main things that you need to be looking out in a question or in an event. These are the four main things that you need to be looking out for in a question or an event in order to see if it can be binomially distributed. And just one little lesson is binomial is 2, so hence being 2 outcomes. So that's just a little way you guys can remember that. So the first aspect is there needs to be 2 outcomes, either success or failure. Number 2, there has to be a fixed number of trials. Number 3, each trial is independent. And number 4, the probability of success and the probability of failure is 100% of the sample space. Okay, so when you're looking at a question, in order for you guys to figure this out, you need an equation, right? So I'll be giving you guys an equation that is essential for you to use in order to solve. So if you guys would just give me a minute, I will write down the equation. Okay, so this is the equation to solve for binomial distributions, and this reads n choose r times the n choose r times times p to the power of r times 1 minus p to the power of n minus r. So as you can see, there are 3 variables that are present: n, r, and p. So if you guys are wondering what each of these letters stands for, n stands for the number of trials. So n stands for the number of trials. R stands for the number of successes that occurs. So successes. And P equals to the probability of the success occurring. So in a sense, this is when you look at a question, it's kind of like a puzzle, trying to figure out what aspects of the question correspond to which of these numbers or variables. So n choose r times probability to the power of success times 1 minus the probability to the power of the total number of trials minus the number of successes. And as we learned before, this right here is the same as n, sorry, it looks like an h, but n factorial divided by r factorial times n minus r factorial. Yeah, so just keep in mind this equation right here as we go along into examples, because this is essential for you to, and it will definitely help you to solve the questions. Okay, so the first example that I'll be going through is this question right here. Okay, so let's take a look and read this. A Korean license plate has 6 digits and is formed by randomly selecting from a pool of numbers with 2 4s and 8 other numbers. What is the probability that the license plate will have 1 4? So, just an explanation. So there's a license plate. Oh, sorry. There's a license plate, and it has 6 numbers in it, and each number is selected randomly from a pool of 10 numbers, which consists of 2 4s and 8 other numbers. Okay, so remember what I said earlier about the 4 aspects that are 4 criteria that needs to be in a question for it to be binomially distributed. The first thing is there has to be 2 outcomes, so a success or a failure. So in this case, we can categorize success as the license plate having a number 4. So license plate will have 1 4. So this can be the success, and the failures will be the numbers that aren't a 4 in the license plate. And fixed number of trials. Trials, this is an aspect of the question. So the Korean license plate has 6 digits, so 6 can be the total number of trials, and each trial is independent. And yeah, so let's look at the equation. So n factorial r is the first aspect, right? So and n is the number of trials, and we assign that 6 would be the number, and r, which is the number of successes, and we said that the success is having a 4, and the question reads, what is the probability that the license plate will have 1 4? So there being 1 4 is the r value, which is the success. So that's the first part of the equation, and the second part, as I hope you guys remember, is p to the power of r. So that is the probability, correct? So let's read the question. So the probability of choosing a 4 out of the 10 numbers that are given. So it is formed randomly by selecting from a pool of numbers with 2 4s and 8 other numbers. So there are a total of 10 numbers, but the probability of choosing a 4 is 2, because there are 2 4s and 8 other numbers. So the probability is 2. Right. And r right here, as we previously assigned, is 1. And the next part is 1 minus p to the power of n minus r. And this is equivalent to, okay, well, we don't really need new information. We can just use the numbers given here. 1 minus 2 over 10 is equal to 8 over 10. And then to the power of n minus r. And we know the value of n, and we know the value of r, which is 6 and 1. So n minus r equals 5. Okay, so now what we need to do is just go through with the math. So this equals 6 factorial times 1 factorial, and then 6 minus 1 factorial. Alright, I'll give you guys a couple seconds to figure that out. Okay, so if you did it correctly, then you should have gotten, it was probably very simple. The correct answer would be 6, or the value would have been 6 for 6 choose 1. And the next one is 2 divided by 10 to the power of 1, and anything to the power of 1 is the same value. So this can be 2 over 10, or 0.2. And right here, I'll give you guys some more time to figure this out. So this is 8 to the power of 5, over 10 to the power of 5s. And most likely you will be able to use calculators in these type of questions. And that equals to 0.328 to 3 significant figures. So as we know, you have to multiply all these values right here in order for you to get the probability, right? So let's do that. So 6 times 0.2 times 0.328. That gives you 0.3926. But to 3 significant figures, that is 0.394. So yeah, just let me just get rid of that. 0.394. So that is, so in looking at the question, what is the probability that the license plate will have 1 4? So probability that it will have 1 4 is 0.394 or 39.4%. So that is one example that you guys can use. So something that I didn't mention, is that when you show your work when setting up your equation, what you want to do is you want to write something like this: the probability of x being a certain number, and then the equation that follows, right? So what is the probability that the license plate will have 1 4? So usually the number that goes here is the R number, R value. So this time it's 1. So yeah, that's just a little side note. Okay, now let's go on to the next question. So the next example we'll be looking at is in context of sports. So let's take a look at this. On a football team, the starting quarterback hits his target with an accuracy of 80%. He throws the ball 5 times. Let x represent the number of times he throws the ball on target. Find the probability. So the first probability that we'll be finding is that probability of him throwing accurately to his target 5 times. So let's just take a look at the question. The probability of him throwing accurately is 80%, and he throws the ball 5 times. So 80% is the probability, and 5 times is the total number of trials. So using the equation, it would be total number of trials. Choose R, which is the number of successes. And the next part is probability to the power of R. So probability is 0.8. 0.8 to the power of R, which is 5, times 1 minus P to the power of N minus R. So 1 minus 0.8 equals 0.2. And then N minus R equals 5 minus 5, so that equals 0. So let's go on and do the math. So 5 factorial 5 would equal 1. Okay. So 5 factorial 5 equals 1. And 0.8 to the power of 5, that would equal 0.327, or 3 significant figures, 0.328, 0.328, and 0.2 to the power of 0 would obviously be 1, because anything to the power of 0 is 1. So if we multiply that 1 times 0.38 times 1, we would get the answer of 0.328, which is this same value right here. So let me just write it again just for the sake of it, 0.328. So the probability of him throwing the ball accurately 5 times out of a trial of 5 is 0.328, or 32.8%. Okay, now let's look at part 2 of this question. Oh, whoa. Okay, sorry, I did not mean to do that. Let me just delete this right here. So part 2 the probability, the probability of him throwing more than 3. So let's look at this. The previous examples were x equals a certain number, but this is x is greater than 3. And there are a total number of 5 trials, so there are only 2 numbers that fit for the variable x, which is number 4 and number 5, because the upper boundary, or the maximum number of throws he takes, is 5. So this is the same as probability of x equals 4. Oops, sorry. Probability of x equals 4 plus, let's write that down, probability of x equals 4 plus the probability of x equals 5. Okay, that was very messy, but hopefully you could hear what I said. So let's take it individually. So that when x equals 4, it is 5 factorial 4, and then the probability is still 0.8. 0.8 to the power of the r value, which is 5, and then 1 minus probability equals 0.2, and then the n value minus the r value is 5 minus 4, which is 1. So I'll give you guys some time to calculate that. Okay, hopefully that was enough time. So 5 factorial 4 equals to 5, and 0.8 to the power of 4 equals 0.4096, 4096, multiplication sign, and 0.2 to the power of 1 equals 0.2. Okay, so if you multiply all that, then you should get the value of 0.4096. So just keep that exact value for now, 0.40996. Okay, so this is corresponding to the probability of x equaling 4, but we still have to do x equals 5. So for that case, we have our previous value. We just did that for part A. So, and then we have, I believe the value was 0.328. So let me just write it out. 0.5 0.20 equals 0.328. So now what we do is we add these two values together, because the probability of x being greater than 3 is probability of x being 4 plus the probability of x being 5. So if we add those two values together, you should get the value of 0.7376. So rounded to 3 significant figures is 0.738. So then for this question, the probability of him throwing more than 3 balls on target is 0.38, which is 73.8%. Okay, hopefully now you guys have a good idea of what binomial distributions are and what is needed to find one. Just to recap, the four criteria that is needed is there needs to be 2 outcomes, success and failure, a fixed number of trials. Each trial needs to be independent. The probability of success and failure equals 100. And once again, to remind you guys of the equation that I've been using throughout this whole video, is n choose r times probability to the power of r, or p to the power of r, and then 1 minus p to the power of n minus r. Right here. Okay, well, thank you guys for watching, and yeah.